Hi everyone, welcome back to another math lesson with Sun Devil Learning Labs. My name is Miss Chismar. Today I'm going to be teaching with working with some third grade math skills. So go ahead and grab your whiteboard and your marker, and we're going to go ahead and get started with our warm-up. So we are still working with the commutative property, which means that we can take a math sentence like 5 times 3 and we can make it equal to 3 times 5 just because we reversed the numbers. So I'm going to write that here. 5 times 3 is the same as 3 times 5. That is because 5 times 3 is equal to 15, but if you flip the numbers around and said 3 times 5, that is also equal to 15. So they're the same answers, that we're just using the numbers in reverse. So go ahead and try the next one. 3 times 6 is equal to what times 3? Go ahead and take a second, think about that, write down an answer, and then I'm going to go ahead and show it. So 3 times 6 is equal to 6 times 3. Why? Because 3 times 6 is 18, and 6 times 3 is also 18. Just like that. All right, so let's go ahead and move forward to our application problem. So today's application problem focuses on division, so I'm going to read it out loud. Jackie buys 21 pizzas for a party. She places 3 pizzas on each table. So how many tables are there? So I'm going to write, first thing I'm going to do is write a division sentence. So I have 21, and I know I have 21 pizzas altogether. I know that the number of pizzas in each group is going to be 3. So 21 divided by 3 equals what? How many groups am I going to have all together? So I'm going to use the fair share method. I am going to use a stamp. I'm going to use a star stamp today. I'm going to put 3 pizzas on each table until I hit 21. So I'm going to skip count by 3s until I hit 21. So here's the first one. That is 3, 6, 9, 12, 15, 18, and 21. So now I have equal groups of 3 that add up to 21. So let's see how many tables that's going to be. Let me grab my pen. So I have 1, 2, 3, 4, 5, 6, and 7. So 21 divided by 3 equals 7. So now we know that if there are 21 pizzas and she places 3 pizzas on each table, we are going to need 7 total tables for that to work. I'm going to clear. We're going to move on to today's lesson content. So today we're going to be working on times tables for the number 4. If you've watched any of my previous videos, we have gone over times tables for 2s and 3s. If you haven't, that's okay. I encourage you to go back and watch those though if you're looking for some extra practice. But today we're going to focus on 4s. And we're also going to continue to work on our commutative property of multiplication. So here, we're just going to start with writing our multiplication sentences based on these arrays. So right here, I have 4 rows with 5 in each row. So I have 4 times 5. And how many do I have altogether? That is, we're gonna count by 4s. We're gonna count by 5s on this one, but we have 5, 10, 15, and 20. Because if you count each row, there are 5 in each row, so 4 times 5 equals 20. Here's another one. It's the same array, just a little bit bigger, but this one you can actually see we have 4 rows, 1, 2, 3, 4, and there are 5 here in each column, so 5 in each row, so 4 times 5, once again, equals 20. So if we were to use the commutative property and switch these numbers around, it would look something like this. So we have 4 times 5 is the same as, which is what the equal sign is for. So 4 times 5 is the same as 5 times 4. And why? Because 4 times 5, we just found out, equals 20, but 5 times 4 also equals 20. All right, let's go ahead and take a look at the next problem. So next we have eight rows, and there are 4 in each row. So this time we're going to skip count by 4s until we hit 8. So we're going to do it 8 times. I'm going to do it on my fingers so you can watch, but I want you to say the numbers out loud with me. So we're starting with 4. That's our first number in our skip counting line. Then we're going to 8, 12, 16, 20, 24, 28, and 32. So that's when we skip count by 4s 8 times. That's like saying 4 plus 4 plus 4 plus 4 plus 4 plus 4 8 times. So we just found that 8 times 4, that's an 8, times 4 is equal to 32. Well, now we have an array. We found that by skip counting, but now we have an array to double check our work. So let's look. I have 4, 8, 12, 16, 20, 24, 28, and 32. So you can count all of those to make sure that you are right. And so 8 times 4 is equal to 32. We counted 32 circles. Now let's practice our commutative property. 8 times 4 is equal to 32. But if I were to take this array and flip it so it was sideways, it would have 4 rows of 8. So 8 times 4 is equal to what? 4 times 8, because I'm just taking the numbers and reversing them. All right. Moving right along here. So now this question says, draw an array that shows 4 rows of 3. So I have that right here. We're going to write our multiplication sentence for it. So I have 4 rows, and there are 3 in each row, so 4 times 3. Now I'm going to skip count to find how many circles I have. So I'm going to go 4, 8, and 12. So the answer is 12, but let's double check that. There should be 12 circles here. So I have 3, 6, 9, and 12. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is correct. We have the right answer, and we used skip counting to find that. We're going to take a look at the next one that's going to help us with our commutative property question. So now it says draw an array that shows 3 rows of 4. So now I have 3 times 4, it's the opposite of what we just had, equals 12, because we use commutative property, and 4 times 3 is the same as 3 times 4. I'm going to write that out for us. 4 times 3 is equal to 3 times 4. So again, we're going to double check by counting our array. So we have 4, 8, and 12. So that just shows you how we can use arrays to check our multiplication. We're on the next slide, we're really going to focus on trying to skip count on our own without having to draw an array, because it's a more efficient strategy, and it'll help you solve problems faster. So let's take a look. So skip counting by 4s. So here I have on the top row, I skip counted by 4s all the way up to 10. So I went 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. So I did that 10 times. But this bottom row, this is the number of times we skip count. So when I say 4, I've only skip counted 1 time. When I said 8, that's the same as saying 4 times 2. When I say 12, it's the same as 4 times 3, because I'm counting by 4, skip counting 3 times. So I'm going to write this out for all of them. 16, 4 times 4, because I skip counted by 4 times. This one is 4 times 5, 4 times 6, 4 times 7. Again, because I am skip counting by 4 7 times until I hit 28. 4 times 8, 4 times 9, and 4 times 10. So I'm skip counting by 4s 10 times. I'm going 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. I'm counting by 4s 10 times until I hit 40. That's the same thing as saying 4 plus 4 plus 4 plus 4 plus 4 plus 4 10 times. It's just a quicker way for us to know that. So this is what I want you guys to really focus on, is kind of memorizing almost the skip counting, because it'll be super helpful when you're solving word problems for multiplication, when you're solving for division problems, when you're working on multiplication problems. You won't have to draw the array, which is super helpful and super efficient. It's just another strategy for you to use. If the strategy doesn't work for you, no worries. You can keep working with your arrays. You can keep working with the manipulatives. You can do whatever you need to do in order to master this skill, but this is just another tool for your toolkit. So now I am going to stop sharing my screen real quick so you can see me. And we're going to move on to the problem set for this problem, or for this lesson, I'm sorry. And we're going to do some more skip counting. We're going to take a look at some of the problems that we have. And we're just gonna work together and see what we can find. Okay, so now I have the problem set up here, and it says skip count by fours and match each answer to the appropriate expressions. That's kind of like what we were just doing, except this time we have pictures. So we're gonna start, see if I can get the whole thing on my screen. I can't. We're just gonna start, we already have 4 set up, and it says that we have 4 pieces of fruit here. It's the same as 4 times 1. So we have 4, 8, this is gonna be 12. If I can get my pen to work, there we go. 12. So we have 4, 8, 12, now we have 16, 20, 24, and 28. We'll stop there just for now so we can start matching some of these up. So 4 times 2, because we skip counted 2 times, I'm actually going to draw this along the side so you can see it. 1, 2, 3. This is the number of times that we've skip counted. So it should look at the same. So like here, we skip counted 1 time, so 4 times 1 equals 4. So here we skip counted twice, so 4 times 2 equals 8. Here we skip counted 3 times, and we can't see it on the screen right now, so that's okay. Here we did 4 times, we can see that one right here. This one, we did it 5 times. Here we did 6 times. I'm gonna scroll down a little bit. So now we're going to continue on, and we're going to move our screen down a little bit. And this is 16, so 16, 20, 24, 28, 32, 36, and 40. And we're not going to match this up since we can't see all of them, but that is how we skip count. We skip counted all the way up to 10. Move to the next problem. Mr. Schmidt replaces each of the 4 wheels on 7 cars. So how many wheels does he replace? Draw and label a tape diagram to solve. So we're not going to use a tape diagram just because I don't have enough room, but I am going to draw a picture. So I'm going to use circles to represent the cars. So he used 4 wheels on 7 cars. So I'm going to make 7 groups of 4. 3, 4, 4. And you guys can practice this at home too. If you're still using your whiteboard, you can draw this out with me. If you are at home and want to use some manipulatives, you can grab some counting pieces, like just pieces of pasta, pieces of cereal, anything like that if you want to work on this with me. So we have 5 groups here. We need 2 more. So each group of 4 represents the 4 wheels on my car. And so now I'm going to write my multiplication sentence. I have 4 wheels and I have 7 cars. So how many do I have in total? So now we're going to skip count by our groups. We have 4, 8, 12, 16, 20, 24, and 28. So Mr. Schmidt replaces 28 wheels. I'm going to go ahead and clear that off and scroll down. So Trina makes 4 bracelets. 4 bracelets. Each bracelet has 6 beads. And so we're going to make our beads here. I'm going to use a stamp this time. I'm going to use a star stamp. So she has 4 bracelets with 6 beads on it. So 1, 2, 3, 4, 5, 6. There's 1 bracelet. 1, 2, 3, 4, 5, 6. 2 bracelets. 3, 4, 5, 6. That's 3. And 1, 2, 3, 4, 5, 6. So 4 bracelets. I'm going to write my multiplication sentence. 4 bracelets times 6 beads on each bracelet equals how many? 4. Oh, I'm sorry. We're going to skip count. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Another way we could have done that is we could have used our fingers and skip counted by 4 6 times. So 4, 8, 12, 16, 20, and 24. So she has 24 bracelets. Or I'm sorry, 24 beads for all of the bracelets. So it says, if I can move the screen down. We're going to skip number 4 because I didn't teach that, and we're going to skip to the exit ticket. Arthur has 4 boxes of chocolates, and each box has 6 different chocolates inside. So how many chocolates does Arthur have altogether? Seems very similar to that last problem we just had. So I'm going to use hearts for chocolates because sometimes I like eating the heart-shaped chocolates. Those are fun, especially around Valentine's Day. And we're going to use hearts for chocolates. So 1, 2, 3, 4, 5, 6. That's 1 box of chocolates. 1, 2, 3, 4, 5, 6. There's 2 boxes of chocolates. 1, 2, 3, 4, 5, 6. That is 3. 1, 2, 3, 4, 5, 6. There's our 4th box of chocolates. And so I'm going to write my multiplication sentence. I have 4 groups, and each group has 6 chocolates in them. So how many do I have altogether? Again, we're going to skip count by 4 6 times until we get there. 4, 8, 12, 16, 20, 24. Let's double check our answer here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22, 23, 24. So So we are all set. So now I'm going to stop sharing my screen. That's going to be all for our lesson today. I hope you enjoyed it. We have a few more weeks of Sunday Learning Labs left, so be sure to tune in tomorrow for another lesson, and I will see you next time. Bye.